Hey guys, welcome to 5.4 exponential functions. In this lesson, we're going to be talking about taking the derivative of exponential functions. But before we do that, we're going to go ahead and do a quick review on logarithmic functions and exponentials. Now you guys learned that in pre-cal, a logarithmic function has the log, a base, and the what you're taking the log of, the argument, and then whatever the log equals. You also learned that logarithmic functions are inverses of exponential and vice versa. Exponential functions are inverses of logs, which means I can rewrite the exponentials from the logarithmic expressions. For example, this is my base. In an exponential function, we know that the base is the number, and what are you taking the power of? Well, you're taking the power of y, which is this number here. And then what is b to the power of y equal to? Well, it equals to this argument here, which is x. An easy way to remember this is what I like to call the scorpion tail, or not what I like to call, it's what I've seen known as a scorpion tail. You start from the base and you draw a tail around the y pointing to the argument, so that you start with b. So let me rewrite this. You start with b, you go around the y, and you end at x. Okay, now very similar to exponential equations. X equals e to the y. E is your base, so we're gonna say log base e. Your y is your exponent, and that's going to equal the outside, and then whatever e to the y equals to is the argument of the log. Okay, and if you want to double check, sometimes for me it's harder to go backwards like the way I just did it. One way to check is just to be like this and see if that equals to e to the y equals x, and it does. They're both the same. Okay, so let's go ahead and use these properties to go ahead and solve for letter A. Letter A, we have e to the x plus 1 is equal to 7. Well, let's rewrite this this exponential equation as a logarithmic. E is my base, so it's log base e equals 7. The argument is x plus 1. No, I'm sorry, I think I had that the other way around. I'm sorry. So it's log base e of what it equals to is the argument, and the exponent is the outside of the equation. Well, one thing that I didn't mention right here, that I failed to mention this, that log base e is actually the natural log. So anytime you see log base with an e, you can just rewrite it as natural log. It is the natural logarithmic. So rewriting this is going to be natural log of 7 equals x plus 1. And then solve for x, natural log of 7 minus 1. And then you can use your calculator to find the answer in 3 decimal places. Now we're not going to go to the other problems because really you don't need such a strong skill to solve exponential equations. It is going to be on the AP exam. But the lesson today is the derivatives of exponential equations. So sketch the graph of A without a calculator and B with a calculator. What do you notice? Okay, so we all know that e to the x, y equals any number to the x really, is a parent function and looks something like that. So I'm going to draw this. Okay, and all exponential parent functions cross 0, 1. Now, depending on what the number is, the greater the number, the steeper the exponential function will look like. Now, the more this number gets less to 0, the stretchier horizontally the exponential function looks like. So it all depends on what number you're using. So let me redraw this. So e to the x, and we all know that e is approximately 2.7182 and yada yada. Okay, now if I were to graph this on a calculator, and I don't have my calculator on right now, but if I were to graph this in a calculator, if I were to take the derivative of e to the x, which I don't know yet, and put that on an Inspire calculator, I would see that I get the exact same function. They're both the same. So if the graph of the function is the same as the graph of the derivative, then we say that the derivative of e to the x is e to the x. Now that's just a graphical approach. Now later on, once we learn implicit differentiation, I'll show you guys a proof, a simple small proof of why the derivative of e to the x is e to the x. But for right now, let's just say that the derivative of e to the x is always just e to the x. It is itself. So using chain rule on the next part, using chain rule, if I have a function u, if u is a function of x, and I take the derivative of e to the u, then my derivative of e to the u is the same thing as e to the u, but carrying over the chain rule times u prime. Letter A, find the derivative of y equals e to the 3x squared. Okay, so the derivative dy dx is equal to, well, let's go ahead and break this up. So if I follow my chain rule formula, u is 3x squared. Now, we all know the derivative formula is right above, so I must need a u prime. And what is the prime of u? Well, the prime of u is 6x. All I have to do is plug and chug. And I'm done. E to the 3x squared times 6x. On an AP exam, you'll see it as 6x e to the 3x squared. Letter B. Letter B, we have f of x is equal to x e to the x. Well, let's rewrite that so that it's pretty clear what's going on. What's happening in between x and e to the x? Well, there's a multiplication, which means I just can't take the derivative of each term. So the derivative is not 1 times e to the x. That is a big misconception. Anytime you have a product and you're taking the derivative of a product, you got to use the product rule. So it's going to be the first term. So let me do this in another color. The first term times the derivative of the second term, which is e to the x. Well, we already know what the derivative of e to the x is. It's e to the x plus the second term times the derivative of the first term. Well, what's the derivative of x? It's 1. So it's times 1. So my final answer is x e to the x plus e to the x. Now in a calculus multiple choice exam, they'll have e to the x factored out, so it's x plus 1 times e to the x. You need to be very proficient when it comes to the factoring part of this exam. They get really, really tricky, and you got to know your factoring in order for you to survive the exam. Final example for this video, y equals x cubed e to the negative 2x. Okay, now I could write this as x cubed of e to the positive 2x in the bottom and use a quotient rule, but try to use quotient rule as little as you can, because the quotient rule can just get really ugly sometimes, as you have already seen. So let's just continue. Let's just write it like this. So if I want to take the derivative of x cubed times e to the negative x, it's the first term times the derivative of the second term. I'll let you guys make the connection, so of what I just did, plus the second term times the derivative of the first term. So that it's negative 2x cubed e to the negative 2x plus 3x squared e to the negative 2x. Now in a calculus multiple choice exam, they always like to factor things out. So you have to understand that you could only factor out an x squared an x squared from here, and notice that you have e to the negative 2x, e to the negative 2x. So if I can only factor out an x squared, e to the negative 2x, then I have left a 3 minus 2x. And I'll let you guys make the connections of how I did that.